Alright, so we're in 11.4. We are going to talk about logarithms, but now we're going to be, again, kind of continuing solving them. A little more real-world application with these guys. First problem talks about decibels. Decibels are the way that we measure sound. And so we have this formula that is right here. We are going to use this formula and manipulate it in the next couple questions. This is just going to stay 10. This is log. We are going to get an I, and this is an I/O is the intensity of the threshold of sound. A sound that can be barely perceived, or like the quietest sound that a human ear can actually hear. And then the quantity I is the number of times more intense that sound is than the threshold. So that's the way that they measure it in decibels. And so right in this number one problem, they say that I is equal to 1,000 times I/O, or the initial intensity threshold sound. So what you do is we take the formula. All they do is they take I out and they put 1,000 I in its place, because that's what I equaled right here. Right here. That's what we know that I is, so they take the I out. And then when they simplify, the I0 and the I0 can cancel out. So these guys will cancel out. They can cancel out because they are inside the parentheses with the log. Remember, I can't cancel it out if it looked like this. A log of 1,000 I0 over log of I. These guys would not be able to cancel out then, because I've got to take the log of it, then the log of this, then divide. These would not cancel out, but this is the log, and these guys are in the parentheses together. They will cancel out. So you're left with just 1,000 in there. Remember, this just means 10 to some power. So the question is 10 to what power equals 1,000? And when you do that, it's 3. So this log of 1,000, you can use a calculator if you wanted to. You could actually put that in, and you'd get the answer of 3. And then 3 times 10 is 30. So that's where they got this answer from. There will be a similar question like this on the test, from what I remember. So this now is 500 million times the intensity. So notice it's 500 million. I/O, again, the I zeros cancel out. You take the log of this. Again, you can use your calculator for that answer because it's base 10. And then you times it by 10, and you should get this answer. You should be practicing using your calculator to make sure you're getting those same answers. Alright, for this one now, we're working backwards. Now they're actually giving us the decibels, which is the D, capital B. So they want to know how much more intense it is. They want this, the I. So what we do is take out the dB, and you put 115 in its place. You then, remember the last thing we did was times by 10, so the first thing to get rid of is divide by 10, so they divide by 10, that's where this 11.5 comes from. They then undo log by changing the log form into exponential form. We've done that since 11.1. And then once they get into exponential form, they take and actually do 10 to the 11.5 power, and that's where this number comes from. And then they, so then they get that big number equals I divided by I at 0. And so what they do is they times by I0, which moves it to this side. So you get that big old number, which is right here, times I0, which is where this I0 came from. Alright, so here's some of the stuff that we've talked about so far. If you have your unknown for your argument, that means your unknown is right here. This is the way that you could solve it. If this means that 5 to the 3.1 power equals x, which is what they set up right here, and then you can just put that in a calculator and get your answer. You could do the change of base formula, because what they did right here is they said, hey, this is my B, this is my C, Alright, so over here, in this one, they take this, again, we're still using this right here, and they use the change of base formula to get to this. They say, hey, if this is my C and this is my B, they take the log of x divided by a log of 5. How can I undo dividing by that? You can multiply by the log of 5 and come over here. You put 3.1 times by the log of 5, and you can use that in your calculator. And then this means that 10, right? 10 is the base, so 10 to the second power equals that. So what they do is they go back from log form, they go back to exponential form, and they put 10 to the 2.16 in their calculator, and they get that same answer. So either way, you get right about that same answer. So these are just different things. I'm just going to kind of scroll through properties of how we can solve. If the unknown is the exponent, this would mean that's an 8. So if I have 8 to the x equals 145, which is what they have right there, I can, again, log both sides. That pulls the x to the front, and then they divide by log 8 on both sides. That cancels this out, makes it that. Do it in my calculator, and I get this. Or right away, if you do this and you change it to, use your change of base formula, not from here. If you use from here, you do your change of base formula, boom, you can put that right in the calculator. And again, you get similar answers. Your base is your unknown. Here's some different situations. So you can look at this and you can see, okay, if I have the unknown as my exponent, it's probably going to be better to do my change of base formula. Whereas if I have it in my argument is my unknown, which is right there, then it's probably better to use this way, which is to rewrite an exponential and solve. And then if my base is an unknown, it looks like this is the better way. So they're circling which way is the better way to solve based on which is the unknown. So it's going to be better to solve it in exponential form. All right. This says, circle the logarithmic equation that can be solved more efficiently when written as an exponential. Box, it can be solved more when change of base. And so it just goes through and it talks about how, because my argument is unknown, it's going to be better to write an exponential. Because my exponent is unknown, it's going to be better to do my change of base formula. Because my base is the unknown, it's going to be better to do exponential. So this is just applying that chart that we just learned about which way is going to be better to do. Again, technically, it doesn't matter which way you do them. They're both going to get you the same answer, but this is going to be the better, which means normally faster. So here are those answers on why you would solve those the way you would. If you want to pause and read through them, the boxes and the circles of what they mean. Alright, so number 9, you can definitely stop the video here and try some of these. I'm going to go through all these answers, or at least put them up so you can check through them. But you'll notice, like in this one, you're actually going to have to solve by doing some factoring. And what they do right here is the first thing they do is they take log and turn it into exponential. So 2 to the 4th power equals this whole thing. Again, just because it looks nasty and it gets a whole bunch of other stuff involved in it doesn't mean it changes anything. 2 to the 4th power equals this, and that's what they wrote right here. They then said 2 to the 4th power 16. When I have two different x's with two different powers, I'm never going to be able to make this say x equals by combining x's. So I've got to set it equal to 0 by minusing 16 on both sides. And then I have to solve this by factoring. And that's how they factor it, and they get these two answers. Again, remember, we have to check because we can end up with extraneous solutions. And so when we do that, both of them check out. Same thing with B. Again, they just said 6 to the first power equals all that. Again, I have two different x's with different powers, so I got to set it equal to 0. Factor by solving. Then they go over here and check the answers, and they make sure that they are true. And 6 to the first power equals 6 is true. 6 to the first power equals 6. That is true. Alright, so this one, they give you, and if you read this whole thing right here, they give you the C, they give you the A, and they're going to give you the R, and you're going to be solving for T. So you're not going to be working backwards on this one. And the only thing you need to be careful of is, again, when they give us percents for this R, you've got to change it to a decimal. We cannot use percentage. And then in my calculator, if it was me when I go to do this, I would know that 1 minus this is a 0.8. So I would know that, and in my calculator, I would hit 2 divided by 10. I would hit log, and that would get me this number up here. I would then hit divide in my calculator, and then again 0.8, then log. And so what that's going to do is the calculator is going to give me the log of 8. So that number is going to pop up. It's then going to, if I hit, then I finally hit equals, it's finally going to take this number divided by this funky number and give me the answer of 7.2. Again, you need to be trying those throughout this section. All right, now in this one, our unknown is going to be our R. And so what we have to do is they plug in for everything else, but we got to work backwards and get rid of our R by ourselves. So they say, hey, how can I get this? It is they times by log 1 minus R. Then they times this by log 1 minus R. And so you end up with, because I don't think they do a very good job of this, you end up with log 1 minus R, and then that times 6, and that equals log of 5 over 20, which is 1/4. And then what they do here to get from here to here, how do they get that log by itself, is they divide by 6. So they actually do this in a calculator. They use their calculator, they put 1/4, they hit the log button, and they get some number, they leave that number in there and divide it by 6, and now I have log 1 minus R equals, and it's this number right here. And then to undo, to get the R by itself, you know, the only way they're going to be able to get that R by itself is if this is base 10, they change it to exponential form. They go this to this power equals that. So that's how they end up with this number right here. They then flip this around. They skip a lot of steps. When they go from right here to here, this is 1 minus R equals 10 to the negative 0.1. I don't know why they have those 0, 0. They don't need that. So what they do is they minus 1 and minus 1, so it ends up with a negative R equals 10 to the negative 0.1 minus 1. Well, when they get that answer, they put that in a calculator. They're going to get some answer, and that equals a negative R. So you have to times this by a negative 1, times this by a negative 1, and that's how you end up with this answer. You should try those again in your calculator. Make sure you're getting those same answers. Now this time they're solving for A, and you can look through, and they multiply both sides by this to get this to the other side. When they do, that's where this number comes from, and then they put this on this side. How do I get this? What does this really mean? Well, that means that 10 to this power equals that, the argument, so that's what they did down here. How do I get A by itself? I times by A, I times by A. Then I'd have to divide by this 10 to the power, so they divided the 4 by 10, and that's how they get this answer right here. Again, they skip some steps in between here, so write it fully out and see if you still get the same answers. They are skipping some steps. They didn't show you timesing by a, and then dividing by the 10. So see if you can get that. All right, here's some people that did some stuff wrong. We just want to make sure we don't try these kind of things. When we have, don't forget our rules. If we have two logs of the same base and they are plussing, when I go to put them together, when I put them into the same log, they do not add together. Hopefully you realize that that should have been written as log 5x. Remember, when I multiply, I can break it up into two additions, or if I have two additions, I can make it into one logarithm. And then that might help me solve for this problem. This person right here just dropped the log and said that 5x equals 2. That's wrong. And this person right here, again, just dropped the logs. Somehow thought they canceled out and made it just 5 plus x equals 2. That, again, is wrong. Remember, all of these should be log 5x. So remember those from yesterday. And so here's some more on solutions with this. If I wanted to actually do this question that they were trying to attempt up there, remember, I could smash it together into one log. I can then take logarithm and change it into exponent. So this would be 10 to the second power equals that. Well, 10 to the second power is really 100. Divide by 5 and I get x is 20. Again, I check my answer and it works out. All right, for this one, what they decide to do is when I have subtraction, this is log base 5, this is log base 5. Now, we're going to have to be a little bit careful with this because we have learned some change of base formula, so we might have to use that when solving some of these. So when I have this 45x and I'm minusing this 3, I can smash it together as a division problem. I can get rid of the log by taking 5 to the first power equaling that, which is what they did here. I then know that 5 to the first power is just 5, and 45x divided by 3 reduces to a 15x. 3 goes into 45 15 times, and I'm left with x. I then divide by 15, and simplify it's 1/3, and check my solution. When I have these two right here, this addition, they're same base. Make sure you check that though. Please make sure that they are the same base. They're both base 2. When they're addition, I can just rewrite it as multiplication of 8x cubed with one log. I can then undo log by changing it to exponential. So 2 to the 6 equals 8 to the 8x to the third. 2 to the 6 is really 64. Divide by 8, I get 8. The cube root of x is going to equal 8, so they cube root this side, and that's where they get the 2 from. Alright, this is getting to some real work here. When I have this guy, right, don't get afraid just because it's longer. There is 3 is a base, 3 is a base, so, and there's a plus sign in between them, so I can combine these. But when I combine them, that means I have to multiply. So when I multiply these two together, that becomes x minus 4 times x plus 2. I have to FOIL, and when I FOIL it, I get this answer. So that's where that came from. They then have a log form, so we change log form into exponential form. 3 to the third equals this. I have two different x values. I will never be able to solve this all on my own by just saying x equals getting x by itself. So I have to take x to, or 3 to the third power, which is 27. I then have to move the 27 by minusing 27, and when I minus 27 on both sides, I get 0 over here, and that turns to a 35. You have to factor once you set equal to 0. Here's the way that we factored. They cross this one out because when they go over here and check, it doesn't work. Right here, that does not give me, it gives me an extraneous solution. -5 doesn't work. So that one gets thrown out. All right, so that's a very good example for the stuff you're going to have to go through. Here's some more examples of just to look through. You should be able to see what they're doing here. Remember, if I have a 2 out here, I can pull it back up and make that an exponent, which is what they do. And the reason I'm going to do that is because, like we said the other day, if I can have both sides have a log of something and a log of something, I can just say this is equivalent to this part. And that's what they do. But before they could do that, they had to rewrite both sides, this side and this side, as one log. So they said, okay, we pull this up here and square it, that becomes this. We said, hey, this is a plus sign, so this is going to be timesing by that as one log. And that's where they get this part from. Right here, they just drop the logs because the anti-log, basically both sides, they undo logging on both sides. Then they get this equals that. They square this, which means that you have x plus 1 times x plus 1. You got to FOIL that out. Don't forget that. That's where this comes from. They FOIL this, or they distribute that. That's where this comes from. They combine like terms, and when they do, the x squareds cancel out. When they minus the 2x, this cancels out, and you're left with 1 equals just x. And so it actually turns into, I didn't even have to factor to solve that. They check the answer, and it works out. So that's a very, very good problem for what you'll be seeing. Again, here's some more. You should just try to look through and see what they are doing to smash these guys together. Again, if we write it as one log, then once I get it written as one log, I can drop the logs. Then I can say this equals this. Sorry, I had a minute because I was talking about dropping logs and not talking about going to the bathroom. Anyway, so once we get this set equal, they distribute this out. That becomes that. We have 2 different x's, so I'm going to have to set equal to 0 in order to solve this. So when they combine like terms, they get this and factor it. They get these 2 answers, and it works out. Again, it doesn't matter if it's ln. ln really just stands for log e is really the same thing as ln. So all the ln follows the same rules as logs because it's the same thing. So they smash this side together because this is plus sign. I know these 2 are multiplying. And so this side right here, I don't have to do much to it. Let's see what they do. They just, so once I get ln and ln, they can drop the ln's and make this equal to that. But remember, it has to be just ln equals ln. So you have to smash these together first before you could do just cancel the ln's out. And then they have to say, oh, this has to equal to 0 because I've got x squared and x. So they got to move this over and move this over, and that's how they get this step. Again, they factor it, check their answers, and when they check their answers, -2 doesn't work. So it's very important to make sure you're checking your answers. Here's D. I believe that's it. So we will practice this tomorrow. This is going to be probably the biggest section of this. You've got to make sure you understand how to move stuff around, how to combine like terms, how to factor. It's again coming back up. All right. Good night.